Hi everybody. So we're going to look at some quadratic examples. This is supposed to be the first example of using epsilon delta proofs with quadratic examples. Okay, so we're going to prove using the definition that the limit as x approaches 1 of x squared is 1. So the first thing we're going to do here is just write out the epsilon delta definition of the limit, okay, for this limit and this a value. Okay, so we're just going to say for every epsilon greater than 0, there exists a delta greater than 0 so that x minus a less than delta implies f of x, which is x squared, minus L, which is 1, is less than epsilon. Okay, so during the regular proof, right, we're going to start with the information that the absolute value of x minus 1 is less than delta, and then we're going to try to show that x squared minus 1 is less than epsilon. Okay, so we know the first thing we have to do is pick a value for delta, so let's do that now. We're just going to pick delta. Okay, and so the first thing we're going to do, like we always do when we're picking delta, is look at what we want to be true and try to force that. Okay, so what we're going to do first is go ahead and factor this. Okay, now part of this is good, and that's here we have this x minus a term, okay, and we know that that's going to be less than delta, so we really can force the value of this to be small. Okay, the issue is that we don't really know the size of x plus 1. Okay, we know about x minus 1, but we don't really know about the other factor, which is x plus 1. Okay, so I'm going to look at x minus 1, okay, and see if that can tell me anything about x plus 1. Okay, so I know that this is less than delta. Okay, so if I want to get rid of the absolute value so that I can try to change this into x plus 1, I'm going to say that this is between, right, positive delta and negative delta. Now that's always true for absolute values, right? You guys know that from studying absolute values in your algebra class. Okay, now if I want this to look like x plus 1 instead of x minus 1, I'm just going to add 2 everywhere here. Okay. Okay, so now you can see I do have some restriction about the absolute value of x plus 1, right? But I really want this to not be something to do with delta. I really want it to be a numerical value. Okay, so I'm going to use this trick that people often use with quadratics, and I'm going to let delta be less than 1. Okay, so you know already that you're trying to make delta pretty small, so you might as well pick it to be less than 1. Okay, now why do we pick less than 1 instead of, for example, less than 2? Well, it's just convention, right? You could really pick any whole number and it would work pretty much the same, but because we know delta is usually a really small number anyway, we might as well just say it's less than 1. Okay, and you're always allowed to pick delta, right? That's the whole point of this. So we can pick it be less than 1. Okay, so this would mean, right, if delta is less than 1, okay, that certainly, right, if this is delta plus 2, this is certainly going to be less than 1 plus 2, which is 3, right? All right. So just to talk about this side for a second, okay, delta has to be less than 1. So negative delta, right, is going to be no bigger than negative 1. Okay, so we're going to have the same thing over here, right? So this is going to be no bigger than negative 1 plus 2, right, which is going to be just 1. Okay, so we can safely say that the absolute value of x plus 1 is going to be less than 3. Okay, now this trick with picking delta to be less than 1, okay, this is absolutely a tool that you can use to tell you how big the other factor in the quadratic is going to be. Okay, it works most of the time, and this is a really good trick. Okay, so let's see what that helps us with. Okay, so back in the original thing, we were here. Right, we were at this point. Okay, and now we're going to use that property of absolute values to split up this product. Okay, now remember, this is going to be less than 3. Okay, so we're going to have this be 3 right now. Okay, and then we can divide both sides by 3. That's a 3. Epsilon over 3. Okay, so this thing that we did earlier where we were able to bound the absolute value of x plus 1, right? We were able to say, what is this smaller than, is really what allowed us to replace this with a number and then solve this here. Okay, so just like normal now, we're going to pick that delta is epsilon over 3. Okay. All right. But I wanted to remind you that this was based on the fact that delta is less than 1. Okay, so delta has to be epsilon over 3, but it also needs to be that delta is less than 1. Okay, so we'll talk about how to be precise in saying this later on, but we need to remember, right, that delta is epsilon over 3, but it is also a number that's less than 1. Okay, now most of the time this will naturally occur, right, because epsilon is a small number, so when you divide it by 3, you're going to hope it's less than 1, okay, but we do need to say this just in case epsilon isn't less than 3, for example. Okay, so now that we've gotten some stipulations about our delta, okay, let's look at our actual proof. Okay, now the first thing we're going to do before we start our normal epsilon delta proof is talk about how to bound x plus 1, the absolute value of x plus 1. Okay, so that we're going to start the same way we always do, which is let epsilon greater than 0 be given. Okay, and then we're going to state our choice for delta, right? So we're going to let delta, and remember, we want it to be epsilon over 3, but we also want it to be less than 1. Okay, so we're going to say that delta is the minimum, okay, meaning it's the smaller of the two of epsilon over 3 and 1. Okay, so this is how you really precisely say what we concluded at the end here, right? Which is that delta is usually epsilon over 3, okay, but we also need it to be less than 1, okay? So this is exactly saying you're going to choose the smaller of these two numbers, which will usually be epsilon over 3, but in the case that this is larger than 1, you would select 1, okay? All right. So like I said before, the first thing we're going to do is talk about the absolute value of x plus 1 so that we don't have to interrupt the flow of our proof to do this. Okay, so we're going to say that absolute value of x minus 1 is less than delta. Okay, again, we have to start with this because this is really the only thing that we know. Okay, then we're going to say that this means this is less than 1, okay, which is true since delta is less than or equal to 1, right? It's either less than 1 if this is less than 1, or it's equal to 1 if this is greater than 1. Okay. Now we're going to say what that means. it's going to be between 1 and -1. Okay. And then we're going to add 2 everywhere because, again, we're talking about x plus 1. We want to turn this into x plus 1. So I'm going to add 2 everywhere. Okay. So this tells me that my absolute value of x plus 1, okay, is less than 3. All right. So now that we've taken care of this, where we talk about the absolute value of x plus 1, okay, now we can move on to our normal proof, okay? So we're going to start again with the absolute value of x minus 1 is less than delta, okay? So we're going to use the fact that we're going to do what we always do, right? We're just going to replace this with epsilon over 3. Okay. We know that it is less than that. Okay. Even if epsilon over 3 is greater than 1, this is still less than epsilon over 3. Okay. So now, right, we're trying to make it look like x squared minus 1. Okay. So that means we have to multiply by that absolute value of x plus 1. Okay. But how are we going to do that? So we're going to multiply by the absolute value of x plus 1, right? Because we're trying to turn this into x squared minus 1. Okay. So now we can just simplify this to say that this is x plus 1, x minus 1. Okay. Oops, I forgot one of my absolute values. Okay, and here we're going to change this side into exactly what we want, which is x squared minus 1. Okay, now here's when we really needed to know that this is going to be less than 3. Okay, so by the above part, okay, sometimes people label this, they'll like put a star by it or something, and then you can say by the starred fact or whatever. Okay, this would mean that x squared minus 1 is less than epsilon over 3 times 3. Okay, and now we can is less than epsilon. Okay, and now we're exactly where we want it to be, so we can conclude by definition, okay, the limit as x approaches 1 of x squared equals 1. Okay, so let's talk again about the parts of this that are different than the linear function. Okay, so we had this part at the beginning where we showed that this bound is less than 3. Okay, and then we used that fact here to say that if this is less than that, okay, it's also less than epsilon over 3 times 3, right? Because this has to be smaller than 3. Okay, this is definitely going to be smaller than that. Okay. All right. So I am going to do a couple more examples, so look out for those videos, and I will see you guys soon.